Hey everyone, what's up? Welcome back to Tech Curiosity Stream, your go-to spot for breaking down the complex world of technology into something we can all understand and get excited about. I'm really glad you're here today. We've got a lot of cool stuff to dive into, and I think you're going to find this one particularly interesting. If you're new here, we explore everything from the latest gadgets to the behind-the-scenes code that powers our digital lives. Our goal is simple: to feed your curiosity and make tech accessible for everyone, no matter your background. So get comfortable and let's get started. Before we jump into the main topic, I want to take a quick second to say thank you for tuning in. This channel is all about building a community of curious minds, and your support makes that possible. If you enjoy learning about technology and want to stay updated with our latest explorations, make sure you hit that subscribe button. It really helps the channel grow and lets me know you're enjoying the content. And while you're at it, don't forget to ring that notification bell so you won't miss out on any of our future videos. Alright, with that out of the way, let's talk about what we're diving into today. The topic is something you've probably heard mentioned in tech circles, maybe on a podcast or in a blog post, but you might not know exactly what it is. It's called GraphQL. Now, don't let the name scare you off. It might sound like something super complicated, reserved only for senior developers at giant tech companies. But the core idea is actually pretty straightforward and incredibly powerful. Have you ever used an app on your phone and been amazed at how quickly it loads exactly the information you need? Nothing more, nothing less. Whether you're scrolling through your social media feed, checking the weather, or ordering food, there's a complex dance of data happening in the background. For a long time, the standard way of doing this dance was something called a REST API. It worked, but it wasn't always the most efficient. It was like ordering a set menu at a restaurant when all you really wanted was the fries. You got what you needed, but you also got a bunch of other stuff you didn't ask for. This is where our star of the show, GraphQL, comes in. Think of it as the ultimate a la carte menu for data. It allows developers to build applications that can ask for exactly the data they need, down to the very last detail. So, let's get right into the heart of it. What exactly is GraphQL? At its core, GraphQL is a query language for your API and a server-side runtime for executing those queries by using a type system you define for your data. That might still sound a little dense, so let's break it down with a simple analogy. Imagine you're at a massive, all-you-can-eat buffet. The traditional way of getting data, which we mentioned earlier is called REST, is like being handed a preset plate by the chef. You might say, "I'd like the breakfast plate," and you get a plate with eggs, bacon, toast, and potatoes. It's a fixed package, whether you wanted the potatoes or not. This traditional approach works fine, but it's not very flexible. What if you're not that hungry? What if you only wanted the bacon and a single egg? With the REST approach, you'd still get the entire preset plate. Now let's think about that same buffet, but this time with the GraphQL approach. Instead of asking for a preset plate, you grab your own plate and walk down the buffet line yourself. You have complete control. You can say, "I'll take 2 strips of bacon, 1 scrambled egg, and skip everything else." You get exactly what you want, in the exact amount you want, with no waste. This is the superpower of GraphQL. It's really important to clear up a common misconception right away. When people hear the QL in GraphQL, which stands for query language, they sometimes mistakenly think it's a new kind of database, like MySQL or MongoDB. This isn't the case at all. GraphQL is not a database technology. You can't store data in GraphQL. Instead, it's a language that sits in front of your existing databases, your microservices, or even other third-party APIs. Think of it as a smart and efficient middleman or a universal translator that stands between your application and all the places your data lives. This middleman doesn't care where the data comes from. Your user information could be in a SQL database, your product inventory in a NoSQL database, and your shipping information could come from a completely separate REST API from a logistics partner. To your front-end application, it doesn't matter. It just sends a single, coherent GraphQL query asking for a user's name, the products in their cart, and the shipping status of their last order. GraphQL's job is to receive this one query, go out and fetch the data from all those different sources, and then combine it into one neat, tidy response. To truly appreciate why GraphQL is such a big deal, It helps to know a little bit about where it came from. GraphQL wasn't just an academic project or a random idea, it was born out of real-world necessity at a massive scale. It was developed internally by Facebook back in 2012. At the time, Facebook was making a huge push to improve its mobile applications. The mobile landscape was changing rapidly, with varying network speeds and device capabilities. The engineering team was running into major roadblocks with their existing REST-based API architecture. The Facebook mobile app has a very complex interface. Think about your own news feed. In a single view, you have your profile info, posts from friends, photos, videos, likes, comments, event suggestions, and advertisements. Using a traditional REST approach, loading this one screen would require making multiple round trips to the server. You'd make one API call to get your user info, another to get your list of friends' posts, and then potentially dozens more calls to get the likes and comments for each of those posts. This process, known as underfetching and making multiple requests, was slow and clunky, especially on a shaky 3G connection. The Facebook team realized they needed a new approach, a more flexible and efficient data fetching paradigm designed specifically for the needs of modern, complex applications like theirs. And so, GraphQL was created to solve these exact problems. It was designed to allow the mobile client to describe its complex and nested data requirements in a single request, eliminating the need for multiple round trips. After using it internally for several years and seeing its massive success, Facebook open-sourced GraphQL in 2015. This allowed the entire developer community to start using it, leading to the widespread adoption and excitement we see today. Okay, so we've established that GraphQL is like an a la carte menu for data. But how does the application or the client know what it can order? It can't just ask for random things and hope the server understands. This is where the single most important concept in GraphQL comes into play, the schema. The GraphQL schema is the absolute foundation of any GraphQL API. You can think of it as the comprehensive, strictly enforced rulebook, or the master blueprint that defines every single piece of data an application is allowed to ask for. The schema is written in a special language called the Schema Definition Language, or SDL. It explicitly lists all the different types of data available. Now that we understand the schema is the rulebook, let's talk about how we actually use it to interact with the data. In the world of GraphQL, there are two main types of operations you can perform: queries and mutations. Let's start with the one you'll use most often: queries. A query is exactly what it sounds like. It's how you ask for or read data from the server. It's the queue in GraphQL. So we have the schema, which is the rulebook, and we have queries and mutations, which are the requests. But there's a crucial piece of the puzzle missing. How does the GraphQL server actually get the data? When a query comes in asking for a user's name, how does the server know where to find that name? This is the job of the resolvers. Alright, so we've spent a good amount of time understanding what GraphQL is and how it works with its schema, queries, and resolvers. Now, to really drive home why it's such a big deal, we need to put it head-to-head with the long-reigning champion of API Design REST, which stands for Representational State Transfer. To understand the difference, let's use another analogy. Think of a traditional REST API as a vending machine. It's structured, reliable, and you know what you're going to get. Each item has a specific code, like B4 for chips or C7 for a soda. Let's dig a little deeper into this idea of endpoints, because it's one of the most significant practical differences between REST and GraphQL. In a REST architecture, the API is a collection of numerous endpoints. As an application grows and its data needs become more complex, the number of endpoints tends to explode. GraphQL completely flips this model on its head. GraphQL solves this problem beautifully by design. So we've spent a lot of time talking about why GraphQL is so great, and it truly is a powerful tool. But like any technology, it's not a magic bullet. Another significant challenge that comes with using GraphQL revolves around caching. So, we have covered a lot of ground today on our deep dive into the world of GraphQL. And that brings us to the end of our exploration of GraphQL. Thank you so much for joining me today on Tech Curiosity Stream. I truly appreciate you spending your time with me to learn something new. If you found this video helpful and it sparked your curiosity, please consider giving it a thumbs up. It really helps the channel reach more people. And if you haven't already, make sure you hit that subscribe button and ring the notification bell so you can join us for all our future tech explorations. We have a lot more exciting topics planned, and I wouldn't want you to miss out on any of them as we continue to demystify the tech that shapes our world. Thank you once again for watching. I can't wait to dive into another topic with you all very soon. See you in the next video. Until then, stay curious.